let's begin by talking about three really important questions. Namely, what is calculus? Why are we studying it? And how can we succeed? So the first question, what is calculus? Now, I'm going to give you an answer that I first learned about 25 years ago. So it's been a while. And I was sitting in a class. It was actually a college class. And the student asked a dangerous question. Why are we studying this? It wasn't actually calculus. It was a class that happened later on. It's a class called linear algebra. And I still remember the answer. So I want to share it with you. So here is a very short summary of calculus. You can put it in just a couple of sentences. So the first thing is we understand flat things well. Now what's a flat thing? Well, things such as lines or rectangles or boxes or planes, which you can think of it in a three-dimensional setting. All right, so that's great. I think we all agree. Flat, we love flat. Now, what's the catch? What's around us isn't flat. So in other words, we don't encounter straight lines, we encounter wiggly lines. We don't encounter these nice rectangles, we encounter blobs, and that's the same thing in 3 dimensions. We have like these bean shapes or something even more complicated. And we don't get flat planes, we get these bumpy surfaces. So now our dilemma. The things that we understand really well are not the things that we're able to use because we need to figure out how do we handle these non-flat things. But here's where calculus comes in. It's a brilliant idea. And it says the following. We approximate things which are not flat by things which are flat. And that will help us understand the things around us. So in other words, even though we may not understand these non-flat ideas, by using our flat intuition, we can make things work. Now, when I was much younger and much more flexible, I would demonstrate this by dance. I'd be like, well, it's like we can do very rigid motion, like when but we want to be more smooth, so how do we get that? What's that connection in between the two? And that's what calculus is about. One of the themes that you're going to hear mentioned several times as we go through calculus, and there's a lot of calculus ahead of us. But oftentimes when we're starting a new topic, we'll start saying, well, let's think about a flat thing, or let's think about a small thing, something that we can treat as more or less fixed. Now, calculus as a subject itself is actually split into 2 really important topics. So let's go through and sort of get an idea of how those topics work. Now, the first topic is what's called differential calculus. And here the question is, how is something changing? All right, so what's that type of question look like? Well, what you do is suppose you have a curve. So I'm going to just graph a curve really quickly. So here's a curve. All right, you'll notice it's kind of a hard question to answer. How is this thing changing? Because it's not really a uniform answer. We can see at certain points there are certain behaviors. So for example, there's this long stretch right here where we're going down. Okay, so maybe that's a negative change, going down. Here we're going up. It looks like we're peaking out up here. So it's not like there's one change. So let's make it a little bit more specific. Let's suppose we ask the question, how are we changing right there? That spot right there. What's the change? Now, okay, well, that's a little bit more reasonable question. It looks like we're kind of going downish, all right. But I want to be a little bit more specific. And can we get to that type of specificity? Now, one way to think about, okay, is there something that we do know the change for? And the answer is, we think of a flat thing that we can talk about change, and that's lines. Now, for lines, we can talk about change, because when we talk about change, it's sort of like, how does the change of one thing relate to the change of something else? Change in y over change in x, or rise over run. So for a line, it's a slope. So if this had been a line, life is easy. So now we say, okay, well, maybe it could be a line. How do we do that? Well, we say, let's pull out our magnifying glass. So it's like, okay, we pull out our magnifying glass, and what we're going to do is we're going to blow it up. And so now what happens is we blow it up, and lo and behold, it starts to look a little bit more flat. Now, it's not perfectly flat. It's still, there's a little bit of movement here, but definitely a lot less than what was upstairs. Okay, well, can we do better? Well, yes, we can. What do? Well, let's not pull out our magnifying glass. Let's pull out a really good microscope. All right, good. So we pull out a really good microscope, and we zoom in again. All right, now when we zoom in here, we say, wow, this is pretty good. In fact, it's not exactly flat. There's still a little bit of a bend, but it's definitely making progress. But can we do better? Well, yes, of course we can. We can always do better. We go over to physics and we say, let us borrow that electron microscope, the one that we pay for teaching all these calculus students. And so we zoom in really, really close. And when we zoom in really, really close, lo and behold, what do we see? Well, once we zoom in super, super, super close, it's so flat. It's indistinguishable from a line. So, what were we after? Well, we're after what's the change here? But as we zoom in, we say, aha, I can think about the change here, and this looks flat, which means I can use my technology that's designed for flat things. Now I can talk about the slope of the line. Now you might say, okay, well that seems pretty intuitive. What else is there to calculus? And for differential calculus, that's actually the big idea. You might say, well that doesn't sound so hard. What's hard? Well, you have to get closer and closer and closer. And that idea, getting closer and closer and closer, is a brilliant and beautiful idea, but not easy. And it will surely test our limits. All right, so that's differential calculus. How are things changing? Now, I said there were two types of calculus. Let's talk about the other type. The other type of calculus is called integral calculus. Now, here we want to look at something else. And we're going to look at the question, what's the total? Now, I want to be really careful here, because we're going to go through an example, and this is sort of the quintessential example. And oftentimes when people think about it, they say this is what it's all about. But it's a dangerous example to do. And in our case, we're going to say, what's the total area? All right, so I have this curve. And now what's going to happen is I'm going to go some starting point A, some ending point B, and I'm going to look at this curve. Okay, there's my new B. Yeah, there we go. All right. And we're going to ask the question, how much area is there? So we'll shade this in really quickly. There we go. What's the total? Now, we put on our calculus hats and we say, okay, we're after an area. What's an easy area? Well, an easy area is a rectangle. See, a rectangle, what's special about a rectangle? It's flat. We like flat things. So if I have a rectangle, I can say, well, that would be easy. It would be, your base times your height. And life is good. So I can find areas of rectangles. Now I'm after the area of this shape, which is definitely not a rectangle, see, because it's not a flat top. So what can we do? And here's the idea here. What we're going to do is we're going to break it up into small parts. And then, if we do our job right, each part will be easy for us to understand. All right, so what are our small parts? Well, we slice and slice and slice. So in other words, what I'm doing is I'm taking my shape and I'm breaking it up into lots of little pieces. So I could say that the total area here could be what is found when I add all the little pieces together. Now, what's the advantage of breaking into little pieces? Well, the advantage is if I look at the top, in any little piece, it doesn't change much. See, this is the advantage of looking in close. When you look in close, things tend to not change much. And that's why calculus works so well, is things only sort of change in the big and not in the small. So what we can do is we can say, for any little piece, I can approximate it by a rectangle. So I can just sort of chop things up into rectangles. And now I can say, lo and behold, if I take the areas of these rectangles and I add them up, what I'll get is a pretty good approximation to the total. Now, is it exact? Well, no, it's not going to be exact. Now, why not? Well, because you get these little errors. See, these little errors here are where we have these gaps between what the rectangle is and what it should be. So how can we improve? Well, the way we improve, and this will not sound like such a crazy idea after what we talked about a few minutes ago, is we say, let's break things into even smaller parts. So in other words, smaller and smaller. So now we'll break things into even smaller rectangles. And the smaller the rectangles, the smaller the error. And now we say, okay, well, perfect. Let's keep making rectangles smaller and smaller and smaller and smaller and smaller. The error will get smaller and smaller and smaller and smaller and smaller. So we can find the total. Easy idea. And we're going to figure out how to do it. There, of course, the question is, what does it mean to be smaller and smaller? So you've heard these expressions, closer and closer, smaller and smaller. Again, it's going to test our limits. So that's it. So that's where we're going. And it's going to be a fun ride. And see, keep remembering, think flat. When in doubt, think flat. Okay, so that's what calculus is about. Now, let's get to our second question. Why are we studying calculus? I want to start by giving two sort of unsatisfactory answers and then two more satisfactory answers. It may not be necessarily what you want, but I think they're more honest. Now, the first reason why some people might say we study it is that, you're going to use calculus a lot. Maybe, but for the vast majority of people, including most engineers and even mathematicians, secretly, I don't do that much calculus. I do some. We don't use it that often. It's a good tool to have. Don't get me wrong. And there are certain times when you really need to have it. But you're not going to use it very frequently. And so that's... I'm not trying... Hold on. Don't leave yet. We're going to talk about why you want to stick around. So when I talk about using calculus, I mean like sitting down and like, okay, I'm going to work out something called an integral and I'm going to get all of it worked out, or I'm going to sit down and compute this thing. Well, we have computers for that now. And they're actually a lot better at doing computation than we are. And I'm not opposed to computation at all. In fact, I love using computers for a lot of the things that I do. So, all right. So you probably will not use it on a daily basis for the rest of your life. At least not the actual pull out a derivative. We'll come back to that in a second. Now, the second unsatisfactory answer is I'm being required to take this class. Somebody told me I have to take it, and therefore I have to do it. It's probably true. Calculus is frequently a requirement. I hope that's not the main reason why you're taking this, because I don't want you to come into this class thinking, oh my gosh, this is an obstacle for me to overcome. I have to endure this, but eventually I will be free of this, because you're going to miss out on so much good stuff. There's a lot of good stuff coming. Okay, so those are sort of the two unsatisfactory answers. Now let me get you into two what I think are slightly more satisfactory answers. The first one is I really think this is a wonderful chance for you to develop your number sense and your algebra skills. And you may not do a lot of calculus on a day-to-day basis, but you will deal with numbers. And you will also have to deal with algebraic problems all the time. And so it's good to develop those skills. Now you might think, well, I'm really great at algebra. But I'll tell you, I have a lot of students who come into calculus and they're feeling pretty good. They're like, my calculus skills are, my algebra skills are way up here. And then they take the first quiz or the first exam and they're not feeling so good about their algebra. But then they start to do more quizzes, start to do homework and exams, and they pull themselves back up. So by the end, they're right back where they start in terms of their confidence. But the difference is, here you thought you were good at algebra. By the end of the semester, you actually are good at algebra. One of the best algebra classes is oftentimes calculus. And the reason it works so well is you finally get to see, oh, that's why they made us do that. That's why they have all those trig identities. It makes sense now. That's why we do partial fractions. Who knew? And so there's all these fun things you're going to do. So you're going to get a lot better at your algebra and your number skills, and that's going to be important. But here is, I think, the best reason to take calculus. And that is that calculus is about solving problems. And not just, particular types of problems. Yes, we are going to focus on certain types of problems, but we're going to be developing problem-solving skills. And I'm going to wager that most of the interesting things that are going to happen in your life are going to come when you have to solve a problem. You're going to have to deal with something unknown. It's very unlikely that you get hired by a company and they say, fantastic news, we have problems for you, but we've already solved them before. Here's a manual if you get stuck. Don't worry, it's all there. That's not going to happen. What will happen is if you get hired, they're going to say, oh my gosh, we have this thing. We have no clue what to do. Help us solve this problem. And you want to have that skill set, that ability to solve a problem. And as you go through calculus, we're going to start talking about problem-solving skills. Take a problem apart, break it into pieces, work the individual pieces. That practice of solving problems will make you a better problem solver. And I think that's a really useful tool. There's a famous story of an engineer who was hired to fix a problem. There was a plant, a machine was malfunctioning, and he came in and carefully examined everything and looked around, pulled out a piece of chalk from his pocket, went over, marked a few places, and said, if you weld a beam from here to there, it'll work. It'll solve your problem. And it did work. Later on, they got the bill for the engineer, and $1,000. Now, this was back when $1,000 meant something. And the owner of the company said, I want an invoice. Why did it cost $1,000? I want it itemized. And so they sent the itemized receipt, and it was $1 for the chalk, $999 for knowing where to put the mark. Now, if you think of yourself as a calculator, that's the $1. Because calculators, they're everywhere. They're cheap, and you're never going to beat a calculator. But knowing how to use it, knowing how to solve problems, that's worth something. And you are worth something. Okay, let's go to our last question, our third question. What can we do to succeed? So there's lots of things. I'm only going to mention 4 things for now. But the first thing is make sure that you do problems. And do with a D-O, not view, V-I-E-W. So what do I mean by do problems? Well, I just that. You learn how to solve problems by solving problems. One of the instructors in our department used to call it doing the reps. If you ever go to a gym and are working to get stronger, the way you get stronger is you exercise yourself and you keep developing your skill set. So the more problems you do, the better that you get. Now, when I say don't view problems, there's a tendency some people get is about being passive. It's like, if I am in a room where math is happening, I'm learning math. But no, the way you learn math is to be involved. It's not enough to just be present. You don't learn math by osmosis. It doesn't happen that way. Now, the second thing is to be consistent. In other words, don't try to cram all your studying into a very short time, say before an exam or something. Spread it out. You need time to learn to think. You have to change the way your mind looks at the world. That's not an easy thing because your mind is very stubborn. It doesn't like to change. But if you give it some time, it'll make the connections. It'll start to think in a better, more systematic way. One way I like to think about it is there is no such thing as calculus and chill, which is to mean you can't binge learn math. I guess if there is such a thing as calculus and chill, I've made some really wrong life choices because, boy, I've been missing out. Okay, third thing to talk about, mistakes. I'm going to tell you right now, if you're starting to learn calculus, you are going to make a lot of mistakes. Don't be afraid of it. It's a very natural thing to make mistakes. In fact, mistakes can be very beneficial to you. Making mistakes is not a bad thing. Some of the most beautiful things that have been discovered in the world were products of mistakes. What is a bad thing is making the same mistakes. So in other words, make your mistakes and learn from them. And then you can make more interesting mistakes. See, the more interesting your mistakes are, the more you get to like, oh, yeah. Now, if there's anything that makes me good at doing math, it's the fact that I've had almost 2.5, maybe 3 decades of opportunities to make mistakes. And so I definitely am not error-free. But I tend to make fewer mistakes now. And it'll happen with you. The more math you do, the fewer mistakes you'll make. And mistakes are good. In fact, one way to think about it is a mistake is a chance to learn. And you're about to get a lot of chances to learn. Now, the last thing to talk about, the 4th item that I recommend. Work with other people. And I think that there's this sort of fantasy idea that the mathematician is this solitude person sitting in a room, finding they now use Windows or something because you want to write on a clear glass. It's very cinematic, looks really cool, and they play the music. But math is not a solitary activity. Math is about solving problems, but you don't get the satisfaction until you share it with others. So you want to work with other people. One of the other great things about working with other people is there's a tendency for us not to see our own mistakes. But once we start communicating to other people, then they can spot our mistakes and we can spot their mistakes. So there's a lot to be said. Work with other people. Work with instructors, form study groups, get together. And quite frankly, I think math is a lot more fun. Math is a very social thing when you do it together. All right. Well, there's some advice. Okay, so now we kind of know where we're going, what calculus is, why we should study it, and how to do well. So let's get going.